Hello everyone, my name's Jeff. I go by okgold online. I make VR dance experiences within VRChat. So it's like you're like uploading a world, like you make worlds in Unity. I do all the meshes, the light mapping, everything. It's very much like game creation, like you're making things, you're writing scripts in C#. But then you're like uploading it, and like people can join, they bring their own avatar into the space that they've uploaded themselves in Unity. So it's very like dynamic, it's very moving. So I run these like dance experiences with like 80 to 100 people. They join in, we like feed in like a stream of like audio and video into the space, and it's really fun. So one of the big problems that we have within that scene is that everyone's bringing their avatar in, they're bringing their own shader. So you're trying to like light them in the world with like light probes and maybe real-time lights, maybe some like freaky like projectors where you're putting like shaders on top of everyone. But there's no great, like, we struggle a lot with all these options because some of them are really expensive because you already have like 80 to 100 skinned mesh renders just like moving in a space, which is like very unoptimized. And with everyone bringing their own shaders, it gets pretty expensive. So we want to have like solutions for that, and that's what I've spent a lot of time experimenting with and trying to find like new methods for like fixing stuff like that. So we want to have something that's like optimized because we want to like dance together, we want to be together, and we want to like be more immersive. If we're like lagging out with like 10 FPS, that's not like a good experience, right? So I'm trying to find ways to like light people in a consistent way where everyone's like lit the same way. No one has their like minimum brightness up so that they're like standing out in the crowd when we want things to be like nice and dark. And more importantly, no prep. So we want people to like join off their friends if they see that something's happening. We want them to be able to join that as well. So this project that I worked on, it's called Identica, and it was based on the camera set replacement shader command within Unity, within C#. So this basically takes a camera and says, no matter what you're rendering, we want to render it with this new shader. I'm introducing a shader. Every single mesh in the whole camera scene is going to be rendered with this shader. So it's kind of like putting everything together into one spot. The fun part about this, so like I can give it a shader, super simple shader that does everything in one pass, no extra lighting passes or anything, super quick, good CPU, GPU communication. And hopefully we'll be able to light everyone the same way. And it's really interesting how this works because like people are bringing their own shaders in and I'm replacing them, but it passes on the variables. So if they have like a main text or like even like a specular map of some kind, I can receive that on my end, on my shader if I set it up right. So as I said, I'm working within VRChat, so I kind of have like restrictions on what I'm able to do. So I can't access the main camera within VRChat. So instead I have to kind of do this convoluted way of like pushing like a left and right eyeball render texture into the player's view, which was kind of funny. So this is like the convoluted way that I've done that. And a lot of my work was on optimizing this process so that it's like, I was working with like, for example, I was using like render textures that were like created at runtime. So I would like create them on the CPU, but then I realized that like that makes them readable by the CPU, which takes like extra steps. So I wanted to make like render textures that were only available in the project. And then I would just have to like release and renew them when I wanted to change the size of the render texture, which is an important part of this because different people have different headsets. So someone's left-right eye is going to be completely different from a different headset's right-left eye. And if I don't have access to that camera, we have to find out that information. So we had a funny little, this is the spawn area of the event. So basically every time you're looking at this wall here, your CPU is going through the steps of saying like, is the camera that's rendering right now the main screen camera? No? Okay, I don't care. No, I don't care. Yes, that's the main screen camera. Give me all your information about your dimensions, and then we actually have to like plug it into a dummy camera. We have like a camera that's set up just to like put together the correct projection matrix for everyone. And that worked great. Honestly, I was really surprised. We had 120 people come through the event. And I was very impressed that none of them had like weird janky issues with their screen going on, because that gets very disorienting in VR, for sure. Yeah, so this is just the script that I was putting together in C# to try and mitigate that. So just quickly on the world, so I wanted I make all these like very like soft, like round sort of spaces. This is my Blender scene of that. I wanted to have all these like distinct overhead lights. This was like kind of the vibe I wanted. I've seen like old disco clubs that had stuff like this, and I thought of a way that I could like make that work well with the shader that I was writing for this event. And yeah, so this is like, we got like the dance floor over here, and this is like a lounge area in the back of the space. Okay, so writing the shader. So this was my first time writing an HLSL. I've previously just done like node-based shader, but I wanted control. I wanted this to be super optimized, just one pass, super basic. I didn't want to use any outside like light sources. And one solution we use within VRChat a lot is like accessing like a volume of color to do sort of like light probe-esque things, but have it hit different parts of the mesh. But I didn't want any of that. I wanted like super simple, just like light probes, light maps, and just anything else that I could throw that would be really optimized. So this is what the bake of my world looks like. So I basically had every light in the scene was either red, green, or blue, and then I baked that into the light maps. So this is the light maps, the light probes are all red, green, blue. So this is what it looks like in Unity, but then when we interpret it later on, we're going to see how that's a little different. Yeah, and you can see like these are the light probes. So I'm using like light probes. They're picking up the red, green, blue, and so this is all baked data. This is all taken care of ahead of time. So this is, we had a 64 by 64 texture that we were streaming into the world. And so this is what that looked like. So this is, I was working with a visual arts professional, basically, that's a friend of mine. And so she was basically like toggling this and in real time and feeding in the DJ's music and her visuals on this sort of like thing. So we're using these, and then we're like multiplying the color, right? So if something's being hit by green light, we multiply the intensity of the green light by the color that we're feeding in from this. And this is the up-down mask. I mentioned those overhead lights that we had. So I really wanted those overhead lights. This is basically a 2D texture that just gets like thrown down in world space. Because I'm writing the shader, we can have really unique lighting methods, right? So this is an example. So this is like a dynamic capsule, kind of representing like a player. And so this is what their light maps would normally look like, what the baked light probe data would look like. But when we add in the shader, when you do the replacement shader, this is what it looks like. So we get lighting from the world, and more importantly, the top-down lights hit it, just it's a big 2D texture in world space, but I multiply it by a dot product of like a top-down, so that it does this nice like little roundy bit where it's like not hitting it all the way up, it's just like calculating the up-down, which was like a really cool effect for those lights. So you can see, so this is the same thing we were looking at before with the RGB, except these are like the separate lights hitting it, right? So we're like controlling each of these lights independently, depending on the screen. So this is in real time, we can control this. I had a few issues because I ran this event for like a smaller group of people just to like test it out. And I was getting like really bad performance. Like the performance was really bad. And so I started looking into it, and everyone online was like, do not like when you use set replacement shader, when you use this like obscure camera command, it hates shader like multi-compile shader variants. So I had like all these shader variants built into my shader because I'm like, this is so optimized. I'm being like so optimized with shader variants, and it was like tanking performance to do this. And also, I had all these like separate lights, and I also found like anecdotally that like static batching doesn't work very well, which is something that I rely on a lot in my worlds because I have these very like static worlds, and I expect at runtime for it to like merge all of these lights together and for that to be like one draw call, but this was being like 200 draw calls for all the lights. So that's something I had to fix. I had to go back and fix that. Okay, just a couple more minutes. I'll skip to the video. There's some more issues that I had to resolve in that week. So we announced the event. I made a poster. This is like a Blender animation that I put together that announced me and my friends. We're doing a DJ event with Silent, doing the visuals, which was fun. And this is the finished result. So this is like what the event looked like. So we've got like people moving around. This is the VJ Silent. And so she's controlling these lights with her, she's used to doing like DMX stuff. So she's controlling the intensity of these lights left and right. There's 3 unique lights in the space. And it led to like a really nice dance floor. We didn't have that issue where people were like too bright. We were able to kind of like light people dynamically, and it was fun. No, it was cool. This is some hand cam footage that my friend took from the dance floor, and we've got all those like up down lights. Those had their own like I baked like a light, like a texture for those so that it would like only binary turn on and off depending on if that light was supposed to be like hit by the pixel or not. But it was all no runtime, no nothing. This was all just like baked stuff. So yeah, no. So I just wanted to give you guys a taste of the kind of stuff I do with the VR and stuff. So, woo! Thank you. Cool. All right. Thank you.
That's sick as fuck. Like,
Thank you.
like,
It's cool.
it's
Yeah.
so cool.
I'm happy.
No question.